Good day, everyone. Welcome to today's lecture. So we are going to talk about how to use R Studio for time series analysis. So let's go. In this R Studio, what's what we need for this time series analysis using R Studio? We need tidyverse. This tidyverse is very important because it's normally come with a lot of package. We need time date and time series forecast. So you have to have this library. So if you have not installed any of it, just press install. Just type install the package, then you write the any package you want, but I've already have it on my system, so I don't need to write it again. So the next step we are going to do here is we are going to import data set that we need. After library or your package, you import the data set that you need. So you come to the environment, you click on import data set from Excel, you browse, then the data set I want to use is FDI here. You click on it, then you open. It's previewing it. So these are the data that I want to use for the analysis. Then you click on import. Yeah, the data is here. So what next? After that, then you go back to your space to type your to do the next step. So firstly, check the class. This data is it a time series data or not? So for you to know whether it's a time series data, you use the command class fdi, you run it. So this one shows that this data is not a time series data, is what data free, that is stable data. So how are you going to change it to time series data? You use it by the command ts. But since I want to use Nigeria economic growth, I short it with this Nigeria economic. So the command we are going to use is what is ts to change it to what to data to time series data. So we are just going to do it ts fdi. Let me clean this one so that in case if you want to write your own, you understand. If you want to do a practice, dollar sign, sorry, you see. So you list all the column in this FDI for me. So we are going for Nigeria economic growth. You click on this one. So the frequency, since the data is a yearly data, so we can't go for monthly. So it's really advisable for us to do what to use yearly. Use one as our frequency since it's a yearly data. If it is monthly data, you can use 12. If the data is collect quarterly, we use what? We use 4. Yeah, it depends on the arrangement we want the data to be in a nutshell. So we have to use like this. Then you run it. After this command, you run it. Now the data is already saved in what your global variable C time series data. You understand? They have turned it to time series data here. So let us confirm whether it's already be time series data by the same command class. You see, class Nigeria economy. You see, it has become time series data. Then let us see the way the data is itself. You see, time series data starts from 1 end in 41. So the frequency is 4. It's what? The frequency is 1. So this will now be, see, the data is already arranged in what? In time series data. Now, what next is to plot the trend to see how in any time series, you have to know how the trend is look like. So let us check how the trends look like. You see the movement of the trend. You see it's going up, going down, going up, going down. So this can be the cause of variation. Maybe this year the economic growth that more that maybe the government supports in the first days, first year, this second, third year, maybe the government did not support well. Here, the government supports. Later on, the government did not support. This can cause by anything. This can cause by war or any other natural disaster. So now, to check the stationarity of the data. So for us to check the stationarity of this data, we use command ACF, which we also known as autocorrelation function. So this is the autocorrelation function. You see this autocorrelation function, it helps us to know whether data is stationary or not. As it is now, you see this, they are going up, coming down, going up, coming down, going up, coming down, and so on. If the data is just maybe like this one start, then it's now going coming down directly without up and down. So this kind of data you can say is not an stationary data and it's not good for prediction. So you have to this kind of data if you use it to predict, there's high tendency for that your prediction not to be accurate if you use the kind of that data that is not stationary for prediction. But this one is good as a stationary, you can use for prediction. And also, the stationary data, at least we are asked what is stationary data. Stationary data, here are the data that the mean and variance does not have significant change in every occurrence. Do you understand? Maybe in the first year, second year, third year, there is no significant change in their mean and variance. So this kind of data is a stationary data and it's very good for prediction. Now, the next thing is to compute ARIMA. So let me clear the console space. So for us to clear the console space, we just use Control L. So now let us compute for ARIMA now. And run it. See, this is all the possible ARIMA that we have. So it will bring out the best model by itself. You don't need to disturb yourself about that. So the best model of this ARIMA is what? ARIMA 200 with 0 mean. This is our best ARIMA model. So this this one can now be what? Can now be useful for us. So we have to forecast. We have to forecast the data now. So for us to forecast the data, we use the command forecast. This K, you see I've already stored this ARIMA with K so that it will be easy for me. I don't need to write all this auto ARIMA again here. I just use it, I declare it as variable here. K is equals to auto ARIMA, Nigeria economy, this and all this command. So we need to it will save time. You understand? So we just K equal A. You see, I even declare this forecast too because I know I will still need it. I even declare it like this. So run it here. So these are our all forecasting and the plots. So this is the plot. You see this blue and this gray and purple. They show the gray show the 90% of this the next 10 years. Sorry, this age means the next 10 years. So if it is 5, the next 5 years I want to use, I will put 5. If it is 6, I will put 6. So this blue and gray, this purple one shows that in the next 5 years, in the next 10 years, I said tendency, there is 90% of tendency that the precision will be around this place. The gray shows that there is 95% that the prediction will be around the place. Hope you enjoyed the class. Please like and share and comment. Thank you. God bless you.